Hi, I'm Dr. Frank Summers of the Space Telescope Science Institute. Welcome to Hubble's Universe Unfiltered. In this episode, we're going to revisit one of our favorite places on the sky, but we're going to see it in a totally new light. This, as you may recognize, is the constellation of Orion. And this is a very rich field in the sky because we've got not only Orion, we've got the brightest star in the night sky, Sirius, we've got Procyon, up over here you've got Taurus, you've got amazing things going on in this region of the sky. However, Orion is a lot more complex than what meets the eye. So this is a visible light image of the stars in the constellation of Orion. It has that familiar X pattern to it. And when you see it in visible light, it's dominated by the light of the stars. Now, if you look at it with a hydrogen alpha filter, which is a filter that's designed just to get the light from glowing hydrogen gas, you get this image. Yeah, a lot different. You see this amazing red structure along here. This is the hydrogen alpha emission, and it comes from a feature we call Barnard's loop. And this is all hot, warm hydrogen gas within the constellation of Orion that's part of what we call the Orion molecular cloud. It actually shows up really well in infrared. So here's a comparison image. Again, this is visible light, and we've drawn in the stick figure of the constellation of Orion in order to guide your eye. So visible light, mostly just the stars. Then you look at it in infrared, you see a totally different view. You see not very many stars, but instead you see all the gas clouds along in here. These are the gas clouds of the Orion molecular cloud. Now this bright region here, this is one you may know about. If you look at invisible light, you can see it. It's a glowing gas cloud. This is what we call the Great Nebula in Orion, or just the Orion Nebula for short. But what is this region up here? It's by the star on the left-hand side of the belt. And that region, if you look at it in detail, in visible light, is the Flame Nebula and the Horsehead Nebula. This is the Flame and Horsehead region around the star Alnitak, which is on the left side of Orion's belt. Today, we're going to go in and take a look at the Horsehead Nebula. Now, for the Horsehead Nebula, Alnitak isn't the important star. The one that matters is this one down here, Sigma Orionis. And it is the light of Sigma Orionis that heats the gas, causing it to glow, creating this red ribbon along here. And the Horsehead is part of a dark dust cloud that is being heated by the light of Sigma Orionis. Now, you can tell there's a dark dust cloud there, not by what you can see, but rather by what you don't see. Over here you can see all the stars that you can see in the background. And behind the Horsehead, all the stars that you don't see, indicating that there's a dust cloud there that is absorbing the light. So you can't look through the dark dust cloud to see things in the background. One of the really nice things about the Horsehead is it actually looks like what it's called. We've got a lot of these nebulas that have these fanciful names, and you look at it and go, I don't see it. I'm sorry, this one is really obvious. Okay? Matter of fact, I think it looks very much like the chess piece for a knight. There you go, boom, Horsehead, Horsehead. It actually looks like what it's supposed to be. Now, you might say, well, it's such an iconic object in the sky, why hasn't Hubble taken a picture of it before? Well, Hubble has, and in the early 2000s, we got this image of the Horsehead Nebula. But it's a dark dust cloud. There's not much detail to it. Even with Hubble's resolution, we can't see much inside it. We want to know what's really going on there. Hubble, using visible light, isn't going to show us. How are we going to get more information? Well, let's back off, and here's the Flame Nebula, and here's the Horsehead here. And instead of using visible light, instead we're going to use infrared light. Now, infrared light has two advantages. One, it's longer wavelength, so it will penetrate deeper into a dust cloud. Visible light can only penetrate so far into the dust cloud. Infrared light, with its longer wavelength, will penetrate deeper. Two, infrared radiation is heat radiation. It comes from cooler temperatures. These clouds are at cooler temperatures, so if they are radiating, they will radiate more in the infrared than they will in visible light. So, you ready for this? This is the visible light view. This, from a ground-based telescope named VISTA, is the infrared view. Isn't that cool? Let's do it again. Okay, so visible light, infrared light. You can see how much more you can see in the Horsehead and Flame Nebula region by using infrared light. And so that's what we did with the Horsehead for Hubble's 23rd anniversary. This is Hubble's old image, visible light of the Horsehead, and our brand new image to celebrate Hubble's 23rd anniversary is that. Quite the difference, isn't it? Okay, I show this at public talks and people give a visible awe. There's a gasp, okay? Visible light, infrared light. Now you can see that in visible light, there are some stars, right? But you can't see many of the background stars. If you take one of these stars, right, and watch it as you go to infrared, it's still there. Now, all those stars are there, but so many more stars, and you can see in the background. You also see all sorts of detail in the gas because the infrared light is being given off by the gas. It's penetrating deeper in to see this structure. What's really cool is if you look in this region right here, we're going to take this and rotate it up for you. You can actually not see just the gas and the stars. You can see background galaxies. There are galaxies throughout here that are millions of light years in the background. We're seeing through this nebula to galaxies tens of millions of light years away. All right, so this is the entire Hubble image that we released for Hubble's 23rd anniversary, the Horsehead Nebula in infrared light. And it's a spectacular image on its own, but we wanted to do something more. One of the groups I work in here at Space Telescope does three-dimensional visualizations. We wanted to take this and take you on a 3D journey into the Horsehead Nebula. Let me show you a little bit of how we did that. First thing is, well, it's a relatively square image. And in order to do a movie, we need it widescreen. So we took the Hubble image and that Vista infrared image, and we put the Hubble image on top of the Vista image. So this is the Hubble image in here, and this outside region out here is the Vista image. We combined the observations from the two telescopes to give us a widescreen aspect ratio. Then we've got to separate this out into layers. All right, and so here is a diagram showing some of what we did. On the back layer here, this black layer back here, are all those background galaxies. We pulled out all those background galaxies, put them on a layer because they're really, really, really far away. So they could be essentially at infinite distance. And they could be one flat layer in the back. Then come various layers of the nebula. And finally, this front layer is the layer of stars. And I'll tell you how we dealt with them in just a minute. So this is sort of like those decoupage boxes where you've got multiple layers, you know, and you look at them and you get a little bit of 3D out of it. We also take it one step further. We don't just do decoupage, we do what we call sculpted decoupage. So if I take that main layer of the horse head, okay, and you can see the horse's head here, this is the grid structure underlying it. What we've done is we've actually gone through and sculpted that layer to produce a sort of, you know, got sort of a mountain range type feel. We go through and we sculpt each layer to give it a landscape feel, the three-dimensional landscape. And just for you watchers of Unfiltered, I'll tell you a secret that nobody else knows. In the video, we actually start with perfectly flat layers all scrunched up next to one another. In the first 5 seconds of the video you're about to see, we actually create the full three-dimensional model. Okay, it starts out totally flat, and then from basically a 2D perspective, and then pulls out into 3D. This was something that Greg Bacon and I decided we ought to try and have some fun with, because we want to do a stereo 3D version of it. We want to have it pull out into 3D. All right, so we had some fun with it. Maybe you can notice it when you watch the video. So we've got these sculpted 3D layers, and we put them into the model. The thing we then have to deal with are the stars. And unfortunately, you can see here are the Hubble stars. They're nice, sharp stars. And the Vista stars are these big blobby things because Vista just doesn't have the same resolution as Hubble does. So instead, what we do is we erase all these Vista stars, and we take templates from the Hubble part of the image, and we replace them. So we go from these blobby stars to relatively sharp Hubble replacements. So we take template stars. We then take those stars, and each one is on its own little postage stamp, and we statistically distribute them through the volume. We don't measure the distance to every single one of those stars. That would be a little bit too time-consuming for us. All right. Instead, we use a statistical model that takes the brighter stars in general towards the foreground, the fainter stars towards the background. And a couple of the stars, because we can tell their color, they're right on the nebula, we sort of hand adjust them in the 3D model to put them down on top of the nebula. This gives us a model that we can believe are scientifically reasonable. I'm not going to say scientifically accurate. It's scientifically reasonable. I, as an astronomer, look at it and I don't find anything majorly wrong with it. It fits with what I would think the Horsehead Nebula would feel like. Here is that three-dimensional journey into the Horsehead Nebula. And you can see the camera starts with a relatively straightforward push, and we're really enjoying the beautiful gaseous landscape. And finally, towards the end, we just do a little bit of a slide to the right so you can get appreciation for this big Horsehead part of the nebula. That video is available online, so you can download it and watch it as many times as you wish. To me, what this infrared image of the Horsehead really brings out is the value of multi-wavelength astronomy. As astronomers, we want to explore the universe in all the colors of the rainbow. But we really want to go further. We want to explore the universe in all the colors of the electromagnetic spectrum. That means going to longer wavelengths like infrared and microwave and radio, but also to shorter wavelengths like ultraviolet, X-ray, and gamma ray. And when we look in these new wavelengths, we're going to see new views of familiar objects. That's why NASA has the Hubble Space Telescope, which does mostly visible light, does a little bit of infrared, a little bit of ultraviolet. We have the Spitzer Space Telescope, which observes in infrared, and we have the Chandra X-ray Observatory that observes in X-rays. In the future, we'll have the James Webb Space Telescope, which will observe in infrared. We're covering the various wavelength bands to get as much information about these objects. And as you look out, you will see new things. You'll get new views. You might discover something unexpected, something unusual. You might find that figurative, or even literal, horse of a different color. Thanks for joining us. We'll see you next time on Hubble's Universe Unfiltered. Hydrogen gas within the constellation of Orion that's part of what we call the Orion molecular cloud. It actually shows up really well in infrared. So here's a comparison image. Again, this is visible light, and we've drawn in the stick figure of the constellation of Orion in order to guide your eye. So visible light, mostly just the stars. Then you look at it in infrared, you see a totally different view. You see not very many stars, but instead you see all you may recognize is the constellation of Orion. And this is a very rich field in the sky because we've got not only Orion, we've got the brightest star in the night sky, Sirius, we've got Procyon, up over here you've got Taurus, you've got amazing things going on in this region of the sky. However, Orion is a lot more complex than what meets the eye. So this is a visible light image of the stars in the constellation of Orion. It has that familiar X pattern to it. All the gas clouds along in here. These are the gas clouds of the Orion molecular cloud. Now this bright region here, this is one you may know about. If you look at invisible light, you can see it. It's a glowing gas cloud. This is what we call the Great Nebula in Orion, or just the Orion Nebula for short. But what is this region up here? It's by the star on the left-hand side of the belt. And that region, if you look at it in detail, and when you see it in visible light, it's dominated by the light of the stars. Now, if you look at it with a hydrogen alpha filter, which is a filter that's designed just to get the light from glowing hydrogen gas, you get this image. Yeah, a lot different. You see this amazing red structure along here. This is the hydrogen alpha emission, and it comes from a feature we call Barnard's loop. And this is all hot, warm hydrogen. Hi. I'm Dr. Frank Summers of the Space Telescope Science Institute. Welcome to Hubble's Universe Unfiltered. In this episode, we're going to revisit one of our favorite places on the sky, but we're going to see it in a totally new light. This, as you